Have you ever clicked on a OneDrive file only to watch it spin forever or suddenly error out? You're not alone. Today, we'll break down exactly what's happening under the hood and how something as simple as a long folder name can shatter your workflow. If you want to finally understand why files on demand break and spot issues before they mess up your team's sync, you're in the right place. What's really behind your files on demand? Meet the core components. If you've ever wondered why you can grab one OneDrive file right away but wait forever on another, you're in good company. Most people think the whole process is just OneDrive doing its thing in the background, and if something breaks, you cross your fingers and hope a reboot sorts it out. But what's actually happening under the hood isn't magic. It's a pretty complex system full of moving parts with a surprising amount of teamwork going on behind the scenes. The core reality people tend to miss is that OneDrive Sync isn't a single program. It's a system made up of four main components, each with its own job and set of rules. If you picture the OneDrive client as just another desktop app, it's easy to assume everything works or breaks inside that one program. The truth is, the OneDrive Sync client acts more like an entire mini operating system inside your Windows environment. It has its own specialized workers, passing files, requests, and updates between each other in real time. And here's where most admins, let alone everyday users, run into trouble. When sync issues hit, they're often treated like some kind of black box error. Users just see red X's or spinning sync icons and figure the whole system is either online or offline. But every single glitch, slowdown, or file error links directly back to a specific part of the OneDrive sync chain. Not just the cloud service, not just the local app, but often one small, underappreciated component quietly misbehaving. So what are these components? The four key players are the file system filter driver, the sync engine, the cache database, and the cloud communication module. Each one has a distinct job. The file system filter driver sits between File Explorer and your actual storage, deciding what Windows shows you and what stays hidden. The sync engine is the brains. It manages which files need to sync up or down, handling all the state transitions and scheduling behind the scenes. The cache database is like a fast access library, keeping key bits of files and metadata ready for quick access. And the cloud communication module, that one's always looking outward, managing the chatty business of pushing changes to and from Microsoft servers. It sounds simple enough, but if you've ever worked in IT, you know systems like these never play out as neatly as the diagram on a PowerPoint slide. Picture it like a relay team. Each component passes the baton to the next, racing to get your files from the cloud to your desktop or back again. If any one runner on the team drops the baton, you're suddenly dead in the water. It's not about the whole system failing all at once, but a single slip throwing off the entire workflow. Here's an example pulled straight from a Thursday afternoon that went sideways for a finance team. They noticed their accounting folder, which was updated several times a week, suddenly froze in place. Downloads wouldn't finish. New receipts stuck in limbo. The initial guess was a permissions mix-up or maybe some internet issue, but digging deeper with Procmon revealed only the cache database had run out of space, a silent failure causing everything else to back up behind it. No network outage, no OneDrive server errors, just a single module tripping up the rest. Every component in this chain is tightly woven with the next. The filter driver needs accurate signals from the sync engine to show the right icons. The sync engine relies on the cache database to avoid repeated slow fetches from the cloud. If the cache corrupts or fills up, the engine's queue grows, and the filter driver can't handshake with the cloud module. Each handoff matters. When a folder hangs or a file stays stubbornly offline, even with a full bar of Wi-Fi signal, tracing the issue often means figuring out who dropped the baton and why. That interdependency also means fixes aren't always what they seem. Running a network troubleshooter or reinstalling OneDrive might do nothing at all if the root issue started in the file system filter. Meanwhile, clearing cache can temporarily solve a stuck file, but if the cloud communication module is lagging, expect things to break again soon. The more you recognize which part is struggling, the faster you can zero in on a real fix, not just treat symptoms. Understanding these distinct jobs puts real power into the hands of anyone diagnosing sync chaos. You're not staring at a single mysterious blob called OneDrive anymore. You're working with a team, each with a specialty, and each with their own favorite ways to mess up. Now, nobody ever remembers these invisible workers until something goes wrong. But spotting which one tripped up is often the difference between losing another afternoon to endless troubleshooting and actually fixing the thing. So file icons in Explorer, cloud checkmarks, spinning dots, they aren't just decoration. Behind every icon is the filter driver, the first and most misunderstood part of the OneDrive team. It lives quietly in the background until it's suddenly center stage when something breaks. Let's take a closer look at what this invisible gatekeeper is actually doing every time you open a folder or save a file, because that's where a lot of confusion and a lot of the headaches really start. The file system filter driver, where file states get decided. Those little icons in File Explorer. The cloud, the checkmark, the plain white outline aren't just for show. They're the first hint that there's a negotiation happening every time you look at a file in your OneDrive. So who's actually making the call about whether a file lives only in the cloud or is physically present on your hard drive? It's not Windows itself making those decisions. That job lands squarely on the file system filter driver, probably the most important OneDrive component nobody talks about until things go sideways. Think of the filter driver as an invisible security guard sitting between Windows Explorer and anything stored on your disk or in the cloud. Every time you open a folder, right-click a file, or copy something into OneDrive, Windows reaches out to the filter driver for guidance. Should this file show up as online only with a blue cloud? Can we instantly open this document, or do we need to fetch it from the server first? The filter driver doesn't just read a flag and call it a day. Instead, it dynamically makes these calls based on what you're doing, what the system policies say, and what status the OneDrive sync engine has passed along. Here's the twist a lot of users don't realize. Windows is always asking. That always available or online only decision isn't static. Say you suddenly decide to right click and mark a folder as always keep on this device. The filter driver picks up on that request, communicates with the sync engine, and starts syncing the file in the background if needed. On the flip side, just hovering your mouse over a dozen files will sometimes prompt it to update what Explorer is showing, depending on what's changed behind the scenes. The icons flicker, shift, turn from clouds into check marks, sometimes almost instantly, and other times after a short delay, if there's more negotiation required with the other parts of OneDrive. Let's make this real. Imagine a design team loads a client folder full of high-res artwork. Everything looks normal in File Explorer, a tidy list with a bunch of cloud icons next to them. The designer double-clicks a massive Photoshop file, and suddenly a file not available error pops up. The knee-jerk response is always to blame the network, but if you dig deeper, it's frequently the filter driver hitting a wall. Maybe a local storage policy stops the file from being downloaded, or the sync engine has flagged it because of a version conflict. Sometimes the limit is as dull as a full cache database, but to users, it just feels like something mysterious broke in OneDrive, that invisible hand deciding what you can see, what you can open, and what state it's in. Is the filter driver working in real time? It intercepts every request, so even just hovering over a new folder can result in an on-the-fly check with the cloud. If a policy has changed, like a new bandwidth limit for downloads, the filter driver has to enforce it. If the device is nearly out of disk space, it may decide the safest thing is to leave a file as online only, even if the user wants to open it. The consequence is that sometimes the file states in Explorer lag behind what's true in the cloud. Most users don't notice subtle delays, but when things jam up, the filter driver is often the first point of friction. It also shapes what breaks if something goes wrong. Ever see a folder packed with files, all with identical icons that never update? That's often a symptom of the filter driver failing to get fresh status from either the sync engine or the database. Maybe it's getting no answer, or maybe the data it's received is conflicting. You might see unavailable files, unchanged icons, or those unhelpful error messages that sound like network issues when the real culprit is local. In these cases, troubleshooting the internet won't do a thing. Restarting the whole sync client might nudge the filter driver back into action, but if the fault is in the way it's interpreting sync state, you'll see the problem again soon enough. And as OneDrive scales up, especially in business environments where policies, cache limits, and device constraints come into play, the filter driver is where cracks start to show. That's especially true if your sync engine is lagging or out of sync with the actual files. Then you'll notice icons in File Explorer that don't match what you expect, or states that never resolve. Recognizing that you're looking at a filter driver hiccup, not a system-wide outage, puts you a step ahead. For admins and power users, it pays to check what the filter driver is reporting versus what the cloud has on record. Tools like Procmon or even digging through the OneDrive sync logs will often reveal if the requests are stalling at the driver level or getting blocked further down the line. In the end, those little icons tell a bigger story than most users realize. They're a window into not just file status, but which part of the OneDrive system is working, struggling, or flat out broken. Now, all these decisions have one thing in common. They depend on good, up-to-date information from somewhere. That somewhere is usually the cache database. If the driver gets old or corrupted info from the cache, it starts making the wrong calls and the user ends up with grayed out files or endless spinning icons. So what makes the cache so critical and so easily breakable? That's where things get interesting fast, especially when speed and reliability start pulling in opposite directions. Cache database, where speed meets fragility. If you've ever wondered why one file opens on your laptop even when you're offline, but another one just hangs there, chances are the answer lies in OneDrive's cache database. Forget the idea of magic or some hidden stash of pixie dust speeding things up. What's really happening is all about how quickly or slowly your device can get its hands on what it needs from the cache. Most users and even plenty of admins glide right by this part of the system because when it works, you don't notice it at all. But when it trips up, you'll see lag, flat out missing files, and some truly head-scratching sync errors. Let's get specific on what this cache actually stores. It's not just a parking lot for entire files. The OneDrive cache database tucks away bits and pieces. File metadata, for example, is there for quick indexing. Things like thumbnails, recent version details, and small chunks of files intended for rapid previewing land here too. That's why you can scroll through folders and preview images even when the Wi-Fi isn't great, or pop open a document you just worked on during yesterday's commute. Instead of sending a call up to the cloud for every detail, OneDrive's cache takes care of it on the spot. That speed comes from smart anticipation, not brute force. But OneDrive's speed advantage isn't unlimited. This is where things start to get interesting and frustrating. The cache has hard limits governed both by the device and by how OneDrive is set up. These limits aren't just numbers on a chart. They impact whether the cache can continue speeding things up or if it becomes a choke point that quietly drags everything down. Every file preview, every quick open, every background sync pushes data into the cache. And once it fills up, it starts making room by evicting the oldest or least recently used data to squeeze new files in. That's when you may start to see files going missing or failing to open just when you need them. There's a classic story from a marketing department that tried moving a huge library of assets, think gigabytes of video files and images, into a new shared OneDrive folder. Everything appeared fine on day one, but by the end of the week, new uploads started throwing errors. Files that were listed as available went into endless syncing or re-downloaded constantly. After enough frustrated back and forth, someone dug into OneDrive's diagnostic logs and spotted it. The cache had quietly maxed out. There wasn't enough room left for even the metadata, so uploads stacked up like planes circling a fogged-in runway. Making the situation even trickier, OneDrive rarely surfaces a helpful error for this. Most of the time, you just see general sync failures or files that disappear, never making it out of the waiting room. So how does cache eviction actually work? In principle, it's pretty logical. When the cache nears its allocated limit, OneDrive goes looking for the stuff it thinks you won't need anytime soon. This means rarely opened files or older versions go out first, making space for new additions or things you've accessed lately. It sounds fair until that automatic decision boots out something you actually need for a meeting right before you go offline. The result is a time bomb for users who think a file is safely synced, only to realize later that the cache let it slip. The cache does more than just store working copies. It plays a behind-the-scenes role in version control, keeping temporary copies while sync jobs complete and holding change logs to compare against what's already in the cloud. That's also how OneDrive protects file integrity. If something goes wrong with your local copy, the cache can smartly serve out an older verified version instead of letting you work with a partial or corrupt file. For offline access, it's essential. It determines what's available when you lose your connection. Because of that, users who travel or move between networks rely far more on cache than they realize until it fails them. Here's where things start to imitate true network problems, even when your Wi-Fi is rock solid. If the cache database gets corrupt or bumps up against its quota, you'll see error messages that resemble plain old internet problems. Files stop syncing, uploads drag on, and Explorer shows outdated icons or blank previews. But unlike network issues, you can't fix this with a router reset. Clearing the cache, repairing the OneDrive client, or in worst case scenarios, deleting the local cache database and letting OneDrive rebuild it from the cloud are potential ways out. The tough part is these remedies do nothing if you guess the real root cause wrong, and often the warning signs are subtle, buried in logs or behind generic failure pop-ups. Knowing the boundaries of this cache is one of the most underrated tricks for solving sync headaches. It explains why files vanish even though they were just visible, or why a laptop fresh from IT setup already has trouble grabbing files. If you spot the clue, a sudden surge in file errors after a big folder move, missing previews, or an odd lag in availability, pulling up the cache stats should be one of your first steps. That simple check might save hours of pointless troubleshooting elsewhere in the sync chain. But no matter how much you manage around cache limitations, sometimes you'll find the system never even had a chance. Hit a path or character limit and you can wave goodbye to smooth sync long before the cache or filter driver gets to weigh in. Let's get real about what actually happens when you cross the line with path length or forbidden symbols, because it's not just annoying, it's a full stop for your process, and the system's just getting warmed up. When limits break the system, how path and character restrictions stop sync cold. If you've ever pulled your hair out over a OneDrive folder that simply stopped syncing, or found out an entire directory has gone missing overnight, there's a good chance you've run straight into one of those boring-sounding technical limits that can quietly destroy workflows. Forget the dramatic cloud outages or throttled networks people love to blame. When you can't see the files you need, or you watch a batch upload grind to a halt halfway through, the culprit is frequently a lot less obvious. It usually boils down to path length limits or forbidden characters, restrictions that seem trivial until they ruin your entire morning. Let's talk specifics. Windows and OneDrive work together to enforce a maximum path length of about 400 characters. That means every piece, from the root drive letter through every folder, all the way down to the file name and its extension, counts against that total. It adds up fast, especially if you're nesting folders deeply or using highly descriptive naming schedules. Add to that a list of characters OneDrive refuses to handle. Think colons, asterisks, question marks, and a bunch of others that show up more often than you'd expect, especially in automated exports or cross-system migrations. Suddenly, what looks like a simple sync job turns into a hunt for files that almost made it into the cloud but never quite crossed the finish line. The thing is, users almost never notice these limits at first. Most people assume any sync issue is probably something with their internet connection or maybe a temporary glitch in the OneDrive service itself. After all, why would a single file name or a long path matter when everything else was working yesterday? But these limits act like a silent bouncer at the door. Files that break the rules just never show up. And unless you're actively looking at the right sync reports or trying to run a diagnostic, the error messages, when they appear at all, rarely explain the root cause in plain language. You get generic "can't sync this file" warnings, but no hint that it's simply too long or contains a stray character. Real-world migrations are where things fall apart in dramatic fashion. Picture a finance department moving decades' worth of reports from a shared drive into OneDrive. On paper, it's a pretty basic process. Copy the folder over and let OneDrive do its sync magic. But the source folders have grown organically for years, names have gotten longer to cram in extra details, and subfolder structures are a tangle of deep branches. By Monday morning, critical audits are missing, project folders stop updating, and staff are stuck emailing files back and forth. Drilling into the logs, IT finds a pileup of files marked unsyncable, most with names or paths that sailed straight past the allowed limit. There's no warning at the beginning, just a cloud of issues later that tie back to one overlooked rule. The sync engine tries its best to recover from these situations, but it's like patching potholes in a road that's already collapsed. OneDrive queues up the offending files, skips them, and keeps working on everything else, but this introduces a subtle risk. Other modules down the line still expect those files to exist. A folder that fails mid-sync might stop batch operations dead or cause apps relying on those files to break unexpectedly. You see cascading effects, incomplete archiving, business process, automation failures, even backup jobs getting stuck because a single file name tripped an invisible wire. Add to that sync errors that sound vague, references to unexpected problems, permission errors, or network timeouts, and you have a recipe for losing hours to troubleshooting that never quite lands on the real issue. What makes this more maddening is how these limits interact with each of the OneDrive client's core parts. The filter driver is the first checkpoint, slamming the door shut the moment you try to create or move a too long file. From there, the cache database might end up holding references to files that never actually synced because they failed the length check or got flagged for a forbidden character. Meanwhile, the sync engine, designed to be reliable but working with what it's given, generates ambiguous errors and keeps plowing forward. Users see nothing more than a failed sync indicator and missing files as the final result. For admins, spotting the telltale signs comes down to pattern recognition. Are batches of files from a deeply nested folder hierarchy failing at once? Do uploads with special characters always result in blank spaces in the destination directory? Is there a sudden spike in so-called network sync failures, but the rest of your SharePoint or OneDrive tenant is green across the board? Those patterns almost always trace back to local restrictions on path length or invalid characters. If you catch them early, it's often as simple as flattening the folder structure or renaming a batch of files with a script. Wait too long and you're stuck untangling a nasty web of missing data and duplicated troubleshooting. The ripple effects hurt productivity fast. One long folder path can block the entire team's shared folder, break power, automate jobs, and suspend crucial document flows without a word of obvious warning. Work grinds to a halt, not because the cloud is down, but because the basics of storage naming weren't followed from the start. If you only look at the surface level errors, you'll waste time chasing non-existent network ghosts or blaming the app when OneDrive is simply doing exactly what it was instructed to do. With all of these moving parts waiting to enforce or stumble over a single character, understanding where each limit triggers, filter driver, cache, or sync engine, means the difference between a quick fix and a week-long headache. When you learn to recognize the signals, you can jump directly to the root and stay ahead of issues as your environment grows. That way, sync failures become a 5-minute script tweak, not a multi-day investigation. Of course, now that every link in the chain is exposed, the components, their limits, the telltale errors, what actually works for diagnosing sync chaos when everything goes wrong at once? The answer is usually less complicated than you'd expect, but only if you know exactly what piece of the machine to watch first. If you've ever stared at a sync error and thought, where do I even start? Now you know why. Every red X and missing file points somewhere along the chain: filter driver, cache, sync engine, cloud. Once you separate out the roles and limits, root causes aren't just easier to find, they're often hiding in plain sight. You'll spend less time second-guessing the network and more time rolling out fixes that actually stick. If this helped cut down on your troubleshooting rabbit holes, share it with your team and stick around for more breakdowns, because clarity is always the best fix.